Hello and welcome back. As we explore in the previous lecture, the Armv8-A data architecture to provide the interface for system configuration, such as MMU, that exception handling, and IRQ and cache. A much more important thing is to identify each system register to configure each configuration. So now, in this lecture, we will explore the key system register that is related to the exception handling. So first, let's dive into the VBAR EL1 register. So here is the list of the system register that is related to exception handling. The first one is VBAR EL1 register, and next one is ELR EL1 register. And here's another one is FAR EL1 register, and the last one is the ESR EL1 register. Those four system register is essential to understand how the exception works in Armv8-A architecture. And from another viewpoint, from debugging perspective, it is important to understand how the system registers can be updated during the runtime when the exception happens. Now, let's begin with the VBAR EL1 register. For this, let's analyze the core part of ARM reference manual that describes VBAR EL1 register. First, VBAR EL1 register means some vector base address register. The VBAR EL1 register is called vector base address register. But actually, in practice, we call the VBAR EL1 register. Why this register is used? And this register is used to hold the vector base address for any exception that is taken to exception level 1. When the exception occurs, then ARM core refers to this system register to the branch into exception vector address. Remember that this system register ends with the EL1. That means whenever exception is taken to exception level 1, so ARM core refers to this system register. But in some cases, the exception is taken to exception level 2 instead of exception level 1. In this case, ARM core refers to the VBAR EL2 register instead of VBAR EL1 register. Another important thing to understand is how this register is configured. For this, let's analyze this example assembly instruction. As you can see, this gray bar indicates the address held by the program counter. That means it is about to run this assembly instruction. As you can see, this assembly instruction is MSR instruction. So if you run this assembly instruction, the value of the X register is written to VBAR EL1 register. Another important question is which value is in the X register. So before this assembly instruction, X register is updated to the address for vectors. What is vector symbol, vector label in this example? So in Linux kernel, the vectors is a symbol for exception handler. So for this reason, address for this vector label is written to the V-bar EL1 register. So this routine is identified in the static code of Linux kernel. And another important thing is the V-bar EL1 register is configured in software at the boot time. So that means V-bar EL1 register is not updated by ARM core at microarchitecture level. So when you bring up your target device, important thing is to configure this system register in software. That is important thing to note when you bring up your target device. Now let's look at how the V-bar EL1 register is used as the case study. So this diagram indicates the controller flow when the exception happens in the user space. From the Arm version 8 perspective, user application, the user space is running at exception level 0. If the exception occurs at exception level 0, then ARM core will jump onto the exception vector address. For this, it will refer to the value of the V-bar EL1 register. Then this offset is added to the value of V-bar EL1 register. This is a way to calculate exception, the vector address, for this kind of exception. That this offset, JRX400, can be observed in the exception vector table. For more information, I want you to refer to another course that explains the exception, the operation in Arm version 8 architecture. So as the first step, exception occurs. As the second step, ARM core generates exception by branching into exception vector address. During this operation, the ARM core refers to the value of V-bar EL1 register. So this is how the exception works in Arm version 8 architecture. So during this operation, every time the exception occurs, ARM core refers to the value of V-bar EL1 register when the exception is taken to exception level 1. So now that we understand the V-bar EL1 register, in the next lecture, we will explore another important system register, that is ELR EL1 register.